my name is JF Brandon, and I'm part of Freescape. This here is what we call the Petal solar tracker. It's one of the first 3D printed solar trackers ever in existence. The idea behind this came from my work in Bolivia when I was an intern at a sustainable energy company called Energetica. While I was there, I was building a 3D printer, and management was like, "What are you going to use this for?" Well, it turns out there's actually really good use for 3D printing. And it basically came from the idea of the fact that they have thousands upon thousands of solar panels installed in Bolivia. It's one of the poorest countries out there, and it's heavily, very rugged. It's very difficult to get, power lines anywhere, so they install a lot of solar panels. To get the most energy out of them would be pretty easy if solar trackers weren't so expensive. So I used my 3D printer to come up with a very simple solution. You print off a special component for that geographic location that points the PV panel in the right direction. The original idea was that you remove one of the motors and the electronics, you reduce the cost, which is really important in lesser developed countries. I took this idea and we started working on it. I applied it to a competition called the 3D40 Challenge, which was in a competition for $100,000 and uses, for people to come up with an idea that uses 3D printing in developing countries. With this idea, I got a lot of exposure to various different companies, one of which was Sunfish Solar, which was looking for a low-cost heliostat for their concentrated solar panel systems. This is where we took this idea and sort of extended it further, improving the resolution, lowering the costs, and trying to make this as most reliable as possible. So if you come here and look at this, essentially it consists of a printed surface like this, made in pieces, because our printer is a little too small for this application right now. And as the system moves across, it moves upwards. If we look down here, you can see actually a motor driving a gear right here, which goes up right into here. So as the motor moves one direction from east to west, the mirror or panel, doesn't matter, is driven upwards. Now this gearing system right here is sort of the most important part. It turns out that the sun moves, the earth actually moves every season. From winter to summer it tilts away or towards the sun. That's a crucial problem. You can't possibly make a different surface for every single day or place it, that's impossible. So what we did is we basically made not just a sort of cam that goes up and down, it's actually in some ways got a specialized surface. And wherever the guide here makes contact with the cam, the panel actually, or the mirror, tilts upwards or downwards more or less. So on one day, you might be going sort of closer to the surface, closer to the inside surface of the cam. At the end of the day, it goes past essentially a turnstile and the gear moves the guide forward. So now it has actually moved the guide ever so slightly forward, to be specific, half a millimeter. So now it is moving forward slightly far. Now, basically the panel is now tilting back even slightly more. So after every single day, the mirror moves farther and farther upwards, following the axial tilt that the Earth is undergoing every single year. The added benefit is that printed components are relatively cheap. Printers are now very effective and very reliable. And the third thing is that you only print what you need. We would call this kind of inventory-less manufacturing. Really good for small businesses like us starting out. The other key advantage is that we don't actually have to rely so much on tooling and stuff like that. We don't have to make molds for this part, specialized mold. We can print different components, ever so slightly different for each location. It doesn't matter whether you're in Kuala Lumpur, whether you're in New York City, whether you're in Siberia. If you need a system, we will print off the cam specifically designed on your geographic location. And for concentrated solar panel systems, or concentrated solar power systems, you would need to actually design a slightly different cam for each location of a heliostat and array. Not a big problem for us. Each cam is still going to cost basically the same.